how to calculate the bar bending schedule of a column. Firstly, let's discuss what is a column. See, here I have drawn a column for your reference. Column is a compressive load taking member which takes compression load. Generally, in a frame structure, when the load transfers from the beams, slabs, ultimately it comes to the columns, and through columns it goes to the foundation, and then foundation to the soil. So here is the member which is known as compression member, or also we usually call it as a column. So here in this column I can show you the references which I have taken. This point level is my ground level, below which 1500 mm I have excavated for my foundation. For foundation, what is supposed to I follow? Firstly, I have provided a 100 mm sand and then 100 mm PCC, above which the foundation's clear cover and the foundation mesh. Above foundation mesh, our BBS column starts. So, in a column, we generally take main bars, and then like this is the section. Here is the one main bar, 2, 3, and 4, and this goes a stirrup, which comes and bend at 135 degree. We call it as a hook also. So in this cross section, I can easily mention that these are my main bars. These two also, all four are main bars. Let's take them as 12 mm. And we have also provided a mesh in footing, which is a 12 by 12 mm road mesh. So let's start and calculate the cutting length of the main reinforcement road. Cutting length. Let's start from the below point. This is my main road. You can easily see here. This portion is called as leg. This portion we call it as leg. Unless until it is stated, we usually take it as 300 mm. And so this point is our 300 mm. Let's write 300. And then we reach to this point. From this point we will come to this point. And how we will come to this point? Here we can see that this is 1500 complete to the depth, and we will subtract like plus 1500. And we have to subtract the depth of PCC, sand, and the dia of mesh rods. So 1500 minus 100. Because we are reaching it here, we will calculate it here. 100 minus 100 minus 50 is the work in the foundation below the mesh, and then 50 mm, then 12 mm dia, and then another of 12 mm dia, which will take us to this point. And from this point, we can see in this section drawing of the column that there is a one line breakwork of 100 mm and ground width of 300 mm. So we will add this also in our main road cutting length bar, then 100 mm plus 300 mm. So far we have reached this point. And now we can see that our slab height from this point, including there is also a plinth level in between. This is our plinth level. So from the ground beam to the bottom of the slab, our height is, here I mentioned, 3150. But we can see that we cannot take completely 3150. Why? Because in columns there is two zones, confining zone and non-confining zone. What is confining and non-confining? Confining where the maximum load transfers and a lot of stress takes place, and non-confining relatively less. So, as per the codal provisions, it is mentioned that the L by 4 portion of the column, this L by 4 at below and this L by 4 portion at above is called as confining zone. Means maximum stress is there and load transfer also takes place there, because from slabs load comes to them and from here this goes to down this way. So that, and the remaining portion, this portion is our non-confining zone. I hope it must be clear to you all that this L by 4 portion and this L by 4 portion is confining zone and this L by 2 portion is non-confining zone. So, while providing reinforcement, we will provide our lap joints in non-confining zone. So, it must be clear. Now we are talking about the lap joints. What is lap joint? See, this is a lap joint. However, I have provided one load is straight, then another load comes overhead, then a joker is here, whose length is generally 6D. What is D? D is dia of bar. Dia of bar. Okay? This is one way of providing lap. Another way, we can also do welding also. Weld. The third way is coupler. These two are also the way. And for these methods, we will prefer these methods generally at the bars above or equal to 32 mm dia. These methods are preferred in this much dia. Else we will provide this method while juggling the bar. And you can also see there is more detailing. This joker is inside the column, not this side. These are like this, not this. This is a wrong way of providing and this is the right way of providing a joker. Because it will, there is a cover and it will affect the cover. So in the same way I have also provided inside, not outside. So I hope this much will be clear to you. And now let's discuss. We are here, and so we have to provide the lap in between this L by 2. Let me make it clear for you once. Here. So how I have to reach here? Which path should I follow? Let's do one thing. We will go complete to the bottom of the slab, then subtract the L by 4. We will reach here in L by 2 zone, and there we will provide lap. So after 300, how much should I get to reach the bottom of slab beam? This is 3150 mm. So let's add 3150. And how much I have to subtract? This L by 4, because we cannot provide lap in L by 4 because this is a confining zone. So we will provide in the zone in L by 2, which is non-confining zone. So we will subtract L by 4 value comes 787.787.5. So after doing the complete solution of this, we will easily get the cutting length of rod 1 of main reinforcement. So we discussed about these two. But there is also another concept in columns that for the corresponding bars or for the just side bars, we cannot provide lap at the same location. You can easily see that in one bar I have provided lap here and in another I have provided here. So in this bar I have provided at the upper L by 4, but we we cannot provide the lab of another bar at the same place. But in alternate cases we can easily do. But in just adjacent case we cannot do. So there must be at least 1 meter gap. We can easily increase it, but there should be a minimum 1 meter gap. So let's do that for another road also. Till here it is also same like 300 mm land until unless stated the other dimensions. Then we will come here till 300 mm. Right. This portion is also same for the second, and remaining values I will write here. So in this portion what we have did, we reached to the number 4, then provided 8, then given an extra length, and then provided a length. Okay. So then add 1 7 8 7.5, and this is, you can see, this is an extra portion. Extra portion which is easily visible in green. What is this? This is a lab length. Generally, lab length as per the total provisions is taken as 50D. Lab length is equal to 50D. D is dia of bar which we are using. It's clear till now? Then we have to provide this 50D also plus 50 into D. We are taking it as like 12 mm road. Then we will reach here. And for our L by 2 we are easily knowing that it is our 1575. 1575 meter. And by keeping this gap, we can easily calculate the 1 meter gap and provide the alternate labs. Now, after providing this lab length, we are done with our this road and this road. For calculating the another road, which is this road, road 2. This is road 1, this is road 1 dash. Let me make it clear. I should write it here. So, now we are calculating road 2. I told you that this is gentle and it is generally measured as 60, but we are not considering it in the calculations because it is very minimum value, and so we will discuss it. We will consider it from here. This is also a lab length, and I told you how much is the value of lab length? It is 50D. Then starting 50D, 50 into 12 plus we reached here. Then we will go this way, then this, and provide after crossing the slab beam above L by 4, the above length of the span, above height of the column divided by 4. After crossing this L by 4 portion, we will provide a lab if we are increasing it to the another level also, or if we are done at this floor, then we will provide to the top subtracting the cover. So let's say it is continuing and we are completing it here. So we have considered 50D, then plus L by 4 of this portion, which is this L by 4, which is 787.5. This is in manual value we have considered, assumed. So we are reached here, but we have to reach here. Then add 350 also, because it is the depth of slab beam plus 350, and above this floor, above ground floor's roof slab, we are having a parapet wall of 1 meter. 1 meter. It means we have to end our road at the parapet wall column, but while subtracting its cover. So plus 1 meter, we are considering all values in M, so we will write as 1000. But we will subtract the cover because we cannot provide it to the just the top, because it will keep it in open and the rest will take place, and our structure will be to 8. So minus 20 cover, 20 mm cover. This will give us the value of rho 2. In the same way, we can also calculate the value of rho 2 dash. But in this case, what we will be doing, we will be considering 50d, then this distance plus L by 4 plus slab beam height plus 1 meter minus cover. In this way, we can easily calculate as much number of bars given in the column section of our project. In the structural drawings, for these we have to read the structural drawings carefully with all dimensions, all covers and all detailings. So I hope this is clear to you all. Thanks for watching and keep sharing the civil Guruji and do join it for further more knowledge.